Good afternoon, everyone. I hope you enjoyed our morning or your early afternoon sessions, depending where you were logging in on. We were thrilled to have so many presenters from around the world and appreciate your patience with some of the technical difficulties we had in the first session, but it looked like those were ironed out in the second session. We'd welcome feedback from folks about your participation at this event. At this point, however, I'm delighted to introduce our first day keynote presenter, Scott Kim. Scott, by way of background, you're an educational game designer and the co-founder of the GameThinking Academy. Been really excited, Scott. All roads, in effect, from people who recommended Math Champions to speak with, ended up invariably coming back to you, recommending that we engage you and invite you to be a keynote speaker. With your background in designing math games for ABC Math and ThinkFun, one of our event co-sponsors, and then working on popular puzzle games like Tetris and Bejeweled. Scott, your background in terms of computer science, graphic design, and music at Stanford University gives you a really interesting range of experiences from which to draw to be able to share your experiences with the folks that are joining for Play every day. So thanks for joining us. Turning it over to you, Scott, and then I believe we'll have a few minutes for questions afterwards, including through the chat. But Scott, delighted to have you join us and turning it over to you.
Thanks so much, Tony. So I'm really happy to be with you, all of you today, to share some of what I've been learning about how to create math games. So as Tony said, I'm an educational game designer. Here's some of the things I've worked on. And for me, how I got there was math has always been a game from the time I was a young kid. I've always played with mathematical ideas as something I enjoyed. Unfortunately, for most people, math feels like a chore. It's something that causes you to go, when are we ever going to use this? Well, I hate seeing people suffer because of math. So I set out from a very young age to make math fun for everyone by turning math into a game. Now, I've spent years learning how to become a game designer so that I could apply it to math. So I want to tell you what I learned along the way. And for today, we're going to start with a worksheet. Let's start by looking at a worksheet. Now, the worksheet is one of the most common elements of we've all seen these in our classrooms. They look something like this. Now, this is from mathdrills.com. It's just very familiar, but think about this. If you were in Super Mario Brothers and you came across this, how would you feel? Well, the truth is, it might be good pedagogy, but it's a bad game. There's no hook. There's no playing pieces. The feedback is terrible. I mean, you fill it out. I don't know if I got it right. And there's no levels. It's monotonous. And sometimes, and you're doing it often under time pressure, which just adds anxiety. We're going to take this worksheet and see how we can turn it into a game. This will be our through-line example. So one way you might think of how to turn a worksheet into a game is to use what's known in the business world as gamification. You might have heard that term. And it means to sort of sprinkle your experience with the elements of a game, to imitate the form of a game. So we could take our addition spreadsheet or our worksheet and add graphics. What happens if you add animals? Makes it a little more appealing. You could add competition, make it a two-player game. You could, a common thing that many teachers do is to put their quizzes into Jeopardy format. It's a little bit more fun. You have a little bit of choice. You can choose which column you want to pick from, and you have visible scores. Again, it's competitive. And you can put it online. Here's a sort of a racing game, I guess, racing theme, but it's really, the thing about all these, and it's really common about gamification is while you're imitating the form of a game, it's still a worksheet, and it's pretty obvious. It's often is a good way to get a short-term boost in attention because it looks more fun, and that matters. And it's kind of a cheap trick, but if it works for you, that's great. But in the long term, what you're telling people is learning is so boring, math is so boring that we're going to have to cover it with chocolate. We're going to have to sprinkle game mechanics on it to make it more fun. That's not a good message. The other approach, and the one I advocate, is called game thinking, and it means to think like a game designer. So what if we approach the worksheet as a game designer? What would that mean? Well, let's start by thinking about how game designers think. Here's the cover of one of the most popular games of all time, Super Mario Brothers. And you see it looks fun. There's a character sticking out its tongue. It looks like a lot of things are happening. So here's the question. How do you think the game designer, Shigeru Miyamoto, thought about this when he was designing it? The answer might surprise you. It's kind of, which is they are thinking about learning. I mean, they're definitely thinking about fun, but they're thinking about fun through learning. Their premise is that kids really enjoy challenge if we can design the experience to be smooth and enjoyable. But the fun really comes from learning. This is a quote from my friend Raph Koster, who wrote a whole book about this topic called A Theory of Fun, real classic in the game design world. So here's the first level of Super Mario Brothers, and it's a masterpiece of learning design. In the space of this one scrolling window, and many of you probably played this and experienced it, you learn everything you need to know about how to run, jump, how the objects work, what happens if you hit something from below or above. It's all done without words, and it's done in a very logical, smooth learning progressions. What's interesting is that, of course, people don't like reading instructions. Most people just want to jump in. This teaches you by playing rather than teaching you by reading about it and then applying the theory later. So how does this game work? Well, there are 4 elements common to all games, and we're going to go over them and then apply them to the worksheet. The first is to have a goal, an overarching thing that you're trying to accomplish. In the case of Super Mario Brothers, the goal is to rescue the princess. Probably the most trite goal you could probably hear, but it works. The second thing that all games have is moves. In the case of Mario, it's running and jumping. Different versions of Mario have some special things. You could run fast, or maybe you could you have a superpower of some sort. But the key thing here is that you've simplified the way you use the game down to just a very small number of very clear actions, so that there's no confusion in the user interface itself. You're not confused about how to use it. That does mean that the first level has to teach you how to use it, but from then on, you're just kind of speaking that language. The third thing that all games have is feedback. The most common thing in games like this is you die. It's the biggest consequence, but of course you can come back to life. So here's Mario, and he's going to jump up these blocks. What happens if you miss? Well, you get immediate feedback, and you learn very quickly how to jump accurately. And the last thing that all games have is levels. The experience is divided into chapters, and each chapter has an ending. So let's apply. So in theory, game thinking means to think like a game designer. Think about long-term, deep engagement. Don't just imitate the appearance of a game, and assume that learning is fun and the challenge is to support the learning every step of the way. And those of you who have designed educational games have done this. Okay, so let's apply this and turn our worksheet into a game. Let's start with a goal. And the goal should be something really appealing. So we're not just saying, you have to do this. We want the player to want to do it. In a traditional worksheet, the goal is to get the right answer. Not very inspiring. In some games, the goal is to save the universe. Well, let's see. Let's try something a little bit more mundane, very common. We're gonna turn it into a competitive game, and your goal is to beat an opponent. Okay, now let's see, moves. You want to streamline the mechanics of playing the game. And why is that? Well, in a traditional worksheet, the mechanics are write your answers in the blanks. That's, first of all, tedious. And if it's anything more complicated than an addition problem, it gets really, you're not sure quite what to do because you're writing in English. I mean, that's a good exercise, but it's very complicated. You can do much simpler. Here's an addition game where you don't type numbers at all. You don't write or type them. You just shoot at expressions. That's a simpler user interface, but it's still getting at the idea of addition. We're going to, for this game, we're going to use dice. We're heading towards a game called Math Dice, by the way. Dice are nice because they're physical and they give you a sense of control. Feedback. Keep the learner on track. Feedback means, well, if you fill out a worksheet, how do you know if you got the answer right? Well, you have to wait till next week. Imagine Super Mario Brothers, you jump, and did you land on the right place? You'll find out next week. That would be terrible feedback. And that's one of the reasons traditional worksheets are so poor. You have this unsettling feeling of you're not sure if you got it right. All computer games, I can pretty much say that, give you immediate feedback. Did you get it right or wrong? Tells you immediately. There's another way to do feedback, and we're going to, Math Dice does it this way, which is social feedback. You can get feedback from other players. So I'll mention, this is an existing game. I didn't work on it. I didn't design it, but I think it's one of the best math games. It's from ThinkFun, one of the sponsors of this event. So it's played with 5 dice. I'll go briefly through how you play it. There are 2 12-sided target dice and 3 6-sided scoring dice. This will get at some of the same skills as the worksheet, but differently. So you roll the 2 target dice, multiply them together to get a target number. 2 times 4 is 8, so that's our target. Then you roll the 3 scoring dice, get a 1, 4, and 5. Now the question is, how close can you get to the target 8 by combining 1, 4, and 5? And you can use any operations you want. Add, subtract, multiply, divide. In this case, you can get exactly 8 by saying 5 plus 4 minus 1. But the goal might be something else. How close could you get if the target was 23? Well, you can't get it exactly, but you can get 24. Maybe you can figure out how. And this is what Math Dice looks like in practice. It's a pretty intense game. The 2 players at the board have rolled the dice, and when they think they can get close, they shout out a number. I can get 22. The other person says, I can get 23. And so then they can be challenged. Oh yeah, show me. And at that point, they have to show what the expression is. Well, so that's how you turn a worksheet into a game. The last thing is levels, and in the case of math, in worksheets, there are no levels. It's just one. You don't get to choose. One thing that's great about all games is you can go at your own pace. You can. Every kid wants to get to the next level, and the next level is ready when you are. In the case of Math Dice, the way it's leveled is you can choose which math operations you use. You can make it harder by including exponents or powers, for instance. So there it is, Math Dice. The hook is to beat an opponent. The moves are to roll dice. The feedback is social from other players, and the levels, you can choose your level of play. If you don't know how to multiply and divide, you can just play it with addition and subtraction. I've seen younger kids do that. I want to end by commenting on why games matter. And of course, this is a theme of the whole event, of this whole conference. Why would you want to play every day? Well, most teachers agree that games are good for math, but most also don't devote much class time to playing games. Why? Because they are under pressure to cover mandated topics, and games are not on the agenda. Games are important because they're like the literature of mathematics. You wouldn't teach reading without books. Well, but we do teach math without games. that's a real shame because kids don't get to engage with mathematics as a fun activity. Games are where mathematical ideas come alive. And therefore, I think it's really important that we do spend class time playing and making games. Making games is like writing stories. That's an important thing too. And I encourage families to play games at home. Have a game night as part of your family rituals. And ultimately, I think that the thing will move it is to put games into the standards so that it's officially sanctioned. Here's an ending quote that's really puts in contrast the difference between school and games. I wish this weren't true, but it's the worst thing a kid can say about homework is that it is too hard. And the worst thing a kid can say about a game is that it is too easy. Okay, thank you very much. That's the talk. You can email me as scott@scottkim.com. I'll open it up to questions. And Nicole, if you could. So first of all, you can type your questions in chat, and Nicole will relay questions to me.
And Scott, can you hear me? Can you hear and see me right now?
Yes.
Okay. Scott, well, I was going to say thank you so much for that presentation. And I know, Scott, that your website, if we could drop a link, or if you maybe Nicole could drop a link, you have all sorts of great resources. But Scott, I couldn't help but notice that you're wearing a t-shirt that is really intriguing, that it says Math Monday. I wonder if you could tell us why you're wearing this particular t-shirt. And I understand that you have an event today related to Math Monday, if you'd like to let folks know about.
Yeah, sure. So I started, Math Monday is a weekly event. We started in schools, but when COVID came along, we turned it into an online event. So every Monday at 2 p.m. Pacific time, 5 p.m. Eastern time, there's half an hour of live math games in Zoom. It's a free event sponsored by the American Institute of Mathematics. And you can sign up for it at mathmonday.net. And yes, there's one happening today, just a couple hours. My colleague Spencer Bowen will be showing an original game he made up. This will be its debut, called Stack Up. And not only do you get to watch it, you get to play it, and it's a game you can continue to play throughout the week.
Thanks, Scott. Scott, given your background with and talking about the steps important for elements of game design, what's the process that you would recommend for people to evaluate the impact of their game for learning outcomes? I wonder if you have any experiences that you could share in that regards as well.
Let's see. I worked one of my biggest projects was working on, it's a good question. It's the bottom line question for educators is, yeah, it was fun. Did it help with learning? And well, there's two answers. The first is, if it helps kids pay attention, that's actually a big part. So one good use of games is to introduce a topic. And then you can follow it up with more conventional lessons. For evaluating, the traditional way is to, use traditional tests. You can test to see if, and there have been studies done, before and after studies. I worked on a product called Mastering Math for ABC Mouse, and they did extensive studies. One thing they did is they worked tests into the game itself. So it was constantly evaluating the kids. That's not a direct answer to your question. I think the thing that thrills parents the most is when their kids start spontaneously wanting to do math and telling them about what they're learning. I think that's the bottom line test that matters to parents. But as a teacher, you're going to want to see differences in test scores. I do understand that.
But Scott, you've actually made the point, however, at the beginning of your presentation, that there are standard tools like math sheets that are being used.
Yeah.
So in some respects, to your point about you're basically turning that into an engaging activity, it's already baked into the fact that you're starting with a curricular resource that there's probably been some testing about,
right.
But it's how to engage students in that in enjoying that as well.
Yeah, that's right. Engagement, unfortunately, ends up very low on the totem pole when educators are creating standards. You say, we want to cover this material and have these test result outcomes. Of course, every teacher wants to engage their kids. The question is how. One kindergarten friend of mine said, well, he just replaces every worksheet with dice. That's a very simple, very doable thing. And it's odd. It's logically similar to a worksheet, but you feel like you're in control. It feels more fun. And that matters. That's
great. And you had mentioned Math Dice, and just for folks that are viewing as well, Bill Ritchie, the founder of Think Fun Games, co-founder, will be talking specifically about Math Dice competitions tomorrow afternoon from 12:30 to 1:30 in one of the gallery walks. Scott, it looks like there's a question for you. Can you see that in the chat that Nicole's posted?
The question is, what are some good resources to access to help turn curriculum material into fun learning games? Good question. Of course, that was the topic of today's talk, but how can you go further? One of my favorite game designers who's written a lot about, very deeply about game design is Jesse Schell, Schell. Shell Games is his, it's a great name, shellgames.com, Schell games.com is the site. And I'm going to put this in chat. One of his colleagues, Sabrina, wrote an incredible resource called Transformational Games. And she goes over in detail how to create a transformational experience using a game. So I'll put that into the, so here's, Nicole, here it is in chat. Please move that to the public chat as well. I definitely recommend that. It's a pretty deep resource.
Perfect.
Okay. So any other questions from either from the audience or from you, Tony?
I'm going to throw another one in, Scott.
Okay.
In the period of time that you've been working in this space, being an advocate, have you seen any trends or changes that are taking place, either because so many people are interested or kids are distracted by sort of video and sort of animated stuff, that people recognize that is, you could either avoid it or sort of engage it, as you've talked about as well. I'm just curious if you've seen sort of over time any sort of trends of greater adoption of game-based approaches or less resistance from administrators about teachers incorporating these good practices in their classroom.
A little of both. I was started into electronic educational games in the early 80s with the Apple II, and there was all sorts of promise then. Certainly compared to where I'd like to see things have moved only a little bit. But that being said, of course, kids in classrooms, it's very common for kids to have computers now, and for teachers to be a little bit more comfortable. One of the things that I find that, like my daughter is in 8th grade now, and one of the things that she's found really fun is use of live events, live quizzes during the classroom. That's a very simple and basic use, but it's very effective. So that's one thing that I've seen that's really happening, and it's a lot of fun.
So like Kahoot or some of those platforms that sort of challenge people to ask questions as well. Scott, I also want to thank you. You've been one of the members that have been part of the design team for Math Attacks, which we launched this morning.
Yeah.
And Scott, what we're really excited by is the principles that you've discussed: goals, moves, feedback, and levels. We're looking for math game descriptions that can be incorporated in low resource households in developing countries. Right. But I think applicants who are sending math games descriptions, or folks that send us, those all seem like good criteria by which that we could benchmark whether or not these are actually good math games. So these provide some useful rubrics for us to make a selection process from.
Good. Yeah, I tried to, there's a lot that goes into game design, but that's boiling down to just the basics.
Scott, there's two more questions for you in the chat if you could see and want to take those.
Okay, let's see. Okay, where would math educators begin? How do you get them going without scaring them back to their worksheets? I think it's basic psychology, which is start small. Start with something you can manage that you're comfortable with. That will vary depending on who you are, of course. A great place to start using games is in daily warm-ups, or you can put up a problem of the week on the board. It doesn't take much time. Start with puzzles or get quick puzzles, or that's where I'd suggest starting, rather than sticking them into the primary curriculum, because that's a little scarier. The other question is, do you see these math games have more or less effectiveness if they're fully online digital, or if there's a hands-on component to them? Well, of course, there's reasons for both. So I'll give you briefly. When I started Math Monday, I would really emphasize in-person physical things. And I think the hands-on component is important for tactile development. I've also done courses where kids make their own games. And what I saw is if you make your own game, you have tremendously more ownership of it. You want to show it to your friends. It's also very social. Anything you do physically, other people can see what you're doing and gather around. But that being said, digital games have a lot of advantages. This is a very wishy-washy answer, I suppose, but it's true. If you're going to do, there are reasons to use both. The reason to go digital is distance doesn't matter. You can do it in the time of COVID. And you can have a record of what you did. You can share it with other people. As a teacher, if you're using like Khan Academy has a dashboard where you can see kids' progress. That's something really unique to the digital form. I would say as a game designer, bridging both, I do design digital games, but I always give myself the challenge of get the same result without the computer, because I really believe that you can get the same result either way. And James Tanton, who's participating in this event, right?
Yes.
He created a game called Exploding Dots, one of the math games I've ever seen. And he implemented it in every possible form. Yes, there's a digital version, but you can, and kids do, play it with rocks and drawing in the ground. It works just fine that way. I think a great idea can be realized either way.
Scott, your website is, thanks for those answers, Scott. You have such great resources on your website as well that I want to just invite people, I think scottkim.com, right?
Yeah.
In terms of your website, including some aspects of this presentation. Scott, any sort of parting words of wisdom? We have another 2 days of this conference. We hope that you'll be able to pop in or out. Any sort of other addition or advice that you might like to give to our viewers?
Yeah, the particular message I hope that got across is what I know that for those of you developing games, I want you to think further than just applying conventional game structures to conventional educational structures. If you do that, you'll get some advantages, but there's more you can do. So dig deeper. And I guess the best way to get there is to play some great math games. Math Dice is one, Prime Climb is another, Set. These are the greats, and take inspiration from them and just how deep they go. Let's see, we have another question. Is there a template, a resource like a website that gives teachers a base, a template to start implementing games and transferring their curriculum to games? That's a great question. I'm not sure. I don't have one. It's like, that's a good idea. Of course, I was trying to advocate for don't just fill in math content into an existing template. But that being said, that's a great place to start. If I were looking, I'd probably look on Teachers Pay Teachers. I bet there are some. You know, there is a Jeopardy website that lets you put in your own content. Seems like a great thing for teachers.
Great. Well, thank you, Scott, for taking the time to join us to be our first keynoter. We're delighted to have your engagement in the course of this event, and we'll be happy to share any additional questions with you, Scott. So there's no live audience that we could see for, say, a round of applause, so I'll just give you my own round of applause. And thank you so much, Scott.
Well, thank you very much, Tony, for inviting me. And I hope you all go out and I will work on getting some better resources for those teachers and put it on my website. The website that I mentioned just a few seconds ago was jeopardylabs.com, where you can make your own Jeopardy game.
Perfect.
Take care.
Well,
Rest of the event.